99% of students fail question 1, part 3 of exercise 2.1 because they have absolutely no idea what the degree of a single number like minus 12 is. Is it 1? Is it 0? Most guess wrong. But don't worry. As we start our exercise today, I am going to give you a 2-second shortcut trick to solve all 5 major textbook questions perfectly. Grab your pen. Let's unlock the secret. Rule number 1. Degree simply means the absolute highest power of the variable in the entire expression. Nothing else matters. Let's look at 4 quick examples before hitting the textbook. Example 1. Look at the variable x. The powers are 2 and 1. What is the absolute highest number? It's 2. So, the degree is 2. Super easy, right? So, let us write the answer. Degree of the given polynomial. This is the correct way of writing the answer. Degree of the given polynomial is 2. Now, example 2. Look at A. We have powers 3, 2 and 1. Don't look at anything else. Just grab the biggest one. The highest power is 3. So, the degree is 3. Now, let's write the answer. Degree of the given polynomial, nothing else but 3. Example 3. It is the ultimate constant trap. Look at minus 20. Where is the variable? It's completely missing. Why? Because it is secretly hiding as m to the power of 0. Write this down in bold. Any standalone number always has a degree of 0. So now let us write the answer in a proper format. Example 4. Look at 5m minus 8. Focus on the m. It has no power written on top. Is the power 0? Huge mistake. When a variable sits completely alone, its invisible power is always 1. So the degree here is 1. Design your own polynomial. Creating your own polynomials. Examiners love asking this. You can use any random numbers you like as long as your highest power perfectly matches the exact degree they ask for. If they ask for a polynomial of degree 1, let us see how to write a polynomial of degree 1. Just write a single variable with a power of 1. Something like 9x minus 1 works perfectly. Next, what if they ask degree 2 polynomial? Now let us try writing this polynomial. Make sure the highest power is 2. Can I write y square plus 11? Yes, because the highest power is 2. Now comes degree polynomial with 3 as the power. So the absolute highest power must be 3. Like this cubic expression right here. You can construct any combination. So 4 z cube minus 2z square plus 1. Okay, after this, let us go to coefficients and constants. A coefficient is simply the friend or neighbor sitting directly in front of the variable. The constant term is the only number at the very end with no variable attached. Look at these 2 examples. Here we are going to find coefficient of x cube and x square in the first example. So, let us look at x cube. Which number is in front of x cube? That's minus 5. So, this is the coefficient of x cube. Let us write the answer. Coefficient of x cube is minus 5. Now, here writing minus is very important in front of 5. Okay, now let us go to coefficient of x square. Can you see which number is sitting in front of x square? That's 4. So let us write the answer. Coefficient of x square is 4. Similarly, let us find the coefficients of x cube and x square in example number 2. Look at x cube. Which number is in front of x cube? That is 8. So, let me write the answer. Coefficient of x cube is 8. Let us go to x square. Which number is seen before x square? There's only the minus sign. So, can I write 1 in between the minus sign and x square? Yes. Now, this becomes our coefficient of x square minus 1 in front of x square. So, coefficient of x square is minus 1. Now, let us go to the next. Finding the coefficient of z in 3z cube plus 6z square minus 5. What is the coefficient of z here? Wait, there is no z term. It is completely missing, which means it is secretly 0z. Can you see any term like z? No. So, here the coefficient is 0. Yes. Now, let us quickly write the answer. Coefficient of z is 0. Similarly, in question number 2, find the coefficient of y. Can you see any term like y here? No. Now, let us go to next pattern of question identifying the constant. What is a constant? It is the only number at the end with no variable. In this first example, which number has no variable? Yes, you guessed it right. That is minus 14. Yes, it is important to write the minus sign. Otherwise, you may lose marks. So, constant is minus 14. Next example, 6x square minus 3x plus 22. Which number has no variable? Yes, 22. So, perfect. You are now fully trained and perfectly aligned with the textbook layout. Come on, let's conquer it. Exercise 2.1, right from your textbook. Question number 1. Find the degrees of the following polynomials. First example. Look carefully. The variable x has powers 2 and 1. Let me circle it out for you. Now, the absolute highest power is 2. So, the degree is 2. Degree of the given polynomial is 2. Let us write the answer. Now, the next example. Again, we are going to find out the degree of this polynomial. Yes, you guessed it right. The highest power here is 2. So, the degree of the given polynomial is 2. The next example, look at minus 9. The exam trap. It is a pure constant number with no variable. It secretly has x to the power of 0. So, its degree is a flat 0. Degree of the given polynomial is 0. And the last one, can you see the variable z is sitting completely alone? Which means its invisible power is nothing but 1. Now, the degree of this polynomial is 1. Let me write the answer. Degree of the given polynomial is 1. Now, we move to the question number 2. Write polynomials of degrees 1, 2 and 3. We can design these however we want. For degree 1, 7x plus 4. For degree 2, x square minus 5. For degree 3, 3x cube. For degree 3, 3x cube, 2x cube plus 4x square plus 5. Yes. Now, question number 3. What are the coefficients of x square and x cube in the polynomial x raised to 4 minus 3x cube plus 6x square minus 2x plus 7? Let us see x square. Which number is there in front of x square? 6. So, I write the answer. Coefficient of x square is 6. Now, what about x cube? Which number is sitting in front of x cube? Coefficient of x cube is minus 3. Do not forget to write the minus sign. Now we move towards question number 4. What is the coefficient of z in the polynomial? 4z cube plus 5z square minus 11. Look closely at the expression. We have a z cube and a z square, but where is the regular z term? It is completely missing. Missing terms secretly mean 0. So, the coefficient of z is 0. Yes. What is the constant term of the polynomial? 9x cube plus 5x square minus 8x minus 10. Which number has no variable? Let us find it out. Yes. Out of the 4 terms, minus 10 has no variable. Now, let us write the answer, and in this way, you have completely conquered textbook exercise 2.1. Here is the challenge time. Can you score 10 out of 10? Yes, it is the time to test your brain. You have watched the concepts, you have seen the textbook solutions, but can you score a perfect 10 out of 10 on my custom exam sheet? What you have to do is, yes, pause the video, open your notebook and start solving the sums. Now that you have completely solved, just put your answers into the comment box. I am pinning a comment below with these 10 challenge questions. Copy it, reply with your answers and drop your exact completion time. The first 5 students to get a perfect 10 out of 10 will have their names pinned to the top of this video forever as our math champions. Go, drop your answers right now.